Okay, so this lesson's on information processing and skill acquisition. Well, the idea of this is that you watch this video, make extra notes, answer the questions, and just gain a good understanding of the basics of information processing before my lesson. And then when we do our lesson, we'll really start doing hands-on application activities to really deepen your understanding of the topic area. So let's have a look at what the specification has to say about this area. So what we're really looking at is this area of input, senses, receptors, proprioception, perception and selective attention in this lesson. And we'll be picking out some real key terms that you need to know definitions for, at least by the end of this video. So when we're looking at the information processing model, the most important and basic model is this one on the screen now, where you've got input, decision making, output and feedback. All the other models that I'll show you today are based around this basic information processing model. The first key word we're going to look at is input, and when we look at input, we're taking in information. So if you're looking at a computer programmer, they'll be inputting information into their computer. In sports scenarios, we're really keen on using the word display. Okay, so this is the information from the environment around us. And the focus of this lesson is going to look at the process from input to decision making and the stages that happen in between this. I'm going to show you a more technical model just now. The first of the more complicated models of information processing is this one here, often referred to as Whiting's model. Now, you don't need to remember the term Whiting, but it is his model, and often some books will refer to this as Whiting's model. It takes in the input from the display, and we see this word from the display, we're talking about the environment. It goes through to the receptor systems here, and the perceptual mechanisms, translatory mechanisms, effector mechanisms, output and feedback. Now remember the basic model. We have input, we have decision making over here, we have output, and then we have feedback. So this more complicated model still has our 4 stages, 1, 2, 3, 4. And really the focus of what this video is looking at between the input all the way around here to our perceptual mechanism. This model of information processing is another alternative to Whiting's model. It's by a dude called Welford, and his model is still based on the same thing, same principles, where we have our input in this section, we have our decision making, we have our output, which is also known as effective control, and then what we have this looping background here is our feedback. So again, we're really going to be focusing on this area here, so we're really going to be focusing on the input to the perception all the way up to decision making in this lesson. So let's look at the input section. Now, when we talk about input, we're talking about information that we receive from the surrounding environment. So let's get a picture. So I've got a picture here of a mountain biker going down what would be quite a steep terrain, and what I want you to think about is what information is coming in to the input for this mountain biker. So this is what the point of view of the mountain biker going down this mountain. And I want you to think about, right, what are pieces of information that he is taking in? Okay, so you can pause this and make a list. So the information that I would say he's taking in from his display, and remember the display is the environment, the surrounding environment. So firstly, you've got this drop that he's got in front of him. That would be the first bit of information. You've got some guy standing there, he'd be probably taking that information. I say he, could be a female. You've got a massive risky drop down here that they'll be taking in. The angle of the bike wheel will be taken into account. The loose rocks here. Probably be thinking about the best line down here. There seems to be a big fissure in the rock. We'll be thinking about what's at the bottom down here. you'd be thinking about which way is he going to go. Is he going to go that way? Is he going to go that way? I know the arrows aren't that good, so is he going to go that way or that way? They're things you'd be taking into account. We'll be thinking, right, how much pressure should we put on the brakes there? How much pressure on these brakes? Which angle is he going to be turning at? Plus, this is just in the picture, there'll be sounds. Obviously, they'll be travelling at a certain speed. All of this information will be collected by the mountain biker before they go for the descent. So, how does he collect this information, I hear you ask? And if we look back to our model, one of the more complicated models, like Whiting's model, we can see that we have our input data from the display, which is taken in by our receptor systems. So the receptor systems are the key to this next area we're looking at. Okay, so let's have a look at these receptor systems. Yes, we are looking at your senses, and often we call them sensory mechanisms or sensory receptors. And as we can see, we've got our 5 senses there. Now, an exam question does like to bring this one up. It'll often say, what are the sensory receptors or sensory mechanisms or senses that are used in a performer playing a badminton shot or some other sort of sporting scenario? Now, you won't be using taste. Okay? That's not really relevant to sports. And you probably won't be using smell. However, most other sports scenarios will use sight, it will use hearing, and it will use touch. Quite often this question is a 3-mark question that asks for 4 points, such as for sensory mechanisms, where you'd obviously put sight down. You can see the opponent hitting the shuttlecock. Hearing, you can hear the sound, the contact that the shuttlecock makes on the racket, and touch, you can feel the grip on the racket. But you need to add in a few more examples of senses, and obviously we only have our 5 senses there. We need to think outside the box. So the first one that we can bring in is proprioception. This is the feeling of the movement we get, usually from internal receptors in the muscles. Obviously we can add in the word feeling as well, which is just an easier way of saying that. And it will actually get us some marks just by putting feel. Similar to this is the term kinesthesis. This is essentially the same as proprioception and feeling. The final word you could bring in here is balance. Pretty straightforward. Balance is used in badminton to keep you level when you're playing the shot. A word of advice: many students have made a mistake by saying hearing, or not putting hearing, by saying sound is a sense. Please be aware that sound is not a sense, sound is what you hear. Hearing is the sense. You won't get a mark if you put sound. So I've used another mountain biking example here to address our input and the information we're gathering from the display using different mechanisms. So using feel, balance, kinesthesis, sight, and maybe sound, we would be gathering information. The information we're gathering is quite significant because we've now got this guy in front doing some wicked move. We've got, obviously we're in the process of doing a wheelie. I can pretty much say this is a bloke, so we'll say he is holding the brake there, taking information, holding the brake, covering the gears there as well. He's got to worry about his line he's taking, which is aiming down here, but also we've got the trees coming on there, trees coming in here. There may be the terrain might be a bit bobbly there, bubbly, whatever the word we're looking for is. We might be taking in sounds from which we can't see in the picture here, but we might be taking sounds from like an eagle swooping in, or a frog on the road, or something croaking, or a dog barking, and all this information is going to come in, and we take that information and have to make a decision. Some of this information is going to be irrelevant, and what we need to do is decide what is important and what is not important. So I want you to watch a video clip which just sort of starts introducing how we determine what information is important and what is not.
The monkey business illusion. Count how many times the players wearing white pass the ball. The correct answer is 16 passes. Did you spot the gorilla? For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it, but did you notice the curtain changing color or the player on the black team leaving the game? Let's rewind and watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold. When you're looking for a gorilla, you often miss other unexpected events. And that's the monkey business illusion. Learn more about this illusion and the original gorilla experiment at theinvisiblegorilla.com.
Selective attention is filtering out irrelevant stimuli.
So with masses of information being gathered in the sports situations and settings, the performers need to use selective attention to filter out the irrelevant stimuli so they can really focus on what's important. So this happens between input and the decision-making phase. So let's have a look at these two exam questions that have come up recently. So we've got this one here about using selective attention, explaining how it works in the game, and this one here is how to improve selective attention. So I want you to have a think about them and bring the answers with you to the next lesson. So as I've already mentioned, we have input and decision making, and the selective attention really fits in this period here. So we get all this gathering this information from our senses, and selective attention really just fits in this gap here. So what we're going to move on to is perceptual mechanisms, which is really making sense of that information that we have filtered out and using. And one of the main mechanisms we use is called DCR. There's a thin exam question with the words perception or perceptual mechanisms in the question. The key term you need to associate with that is DCR. That stands for detect, compare and recognise. And every time you see those words, you must always think, right, I'm going to get DCR in your question. So using a baseball scenario of a batter facing a bowler, the word detect will relate to the detection of the stimuli, which is the ball being pitched towards the batter. To pick up the trajectory of it, the flight, speed, height, spin of the ball, and we would then compare this to our memory traces, the banks of stored information we have in our brains when we've experienced this type of hit ball before, and how to deal with it. Once we've compared it, we'll decide which is the best approach and most appropriate course of action. Once we pick that out, we will then employ it to make the correct hit. So if the ball's taking a dip down as approaching you, you'll compare that and think, right, I need to get underneath the ball, drop your hands, and be able to get under the ball, make the appropriate bounce. So I'm going to use this toy bus of my daughter's to try and explain how perceptual mechanisms works within our brain in the DCR process. So what happens is I have a little bit of stimuli we can use. So stimuli could be the shapes that fit into the holes. Doesn't fit in. Okay, I've got square, triangular shape, heart shape, star shape, pen, whatever shape, hexagon shape, another star shape. So what I'm going to do is detect the stimulus. So I've got my stimuli here. Okay, and my task is to get it inside the holes. And being a PE teacher, it's a difficult task for me. So I have to think back to all the times I've dealt with this type of shape, this simple square shape, and I've used my memory banks to compare what the best action is to fit it into the holes. So I'll look into the shapes that I have in front of me, my square, and think, where's it going to go? So I've detected the stimuli, compared it to my memory, and I recognise the best fit. That's not the best fit. What do? I try it again. I recognise best fit. Yeah, and you go. So in learning circumstances, if I need to find another shape that fits it, I pick it up. Oh, another square, conveniently placed. And I think, oh, I recognise what happens to do there, compare it to my memory, so I recognise and slip it in. Hooray.
That's it. Thanks for watching. To answer all the questions on the presentation, read the chapter that I'm putting on Edmodo, and have a great rest of the half term.